There is a Blackburnian warbler singing too.
I'm waiting
over
to
here.
see that one. I'm waiting to see that one.
I'm waiting for one that's close enough to find.
Fair enough. Oops, I'm gonna end up in the middle of the mud. Sean, it's a beautiful spring day. I'm hearing the redstarts calling, and we're here close to Berlin Pond on a road cut, and we're here to look at the geology. But before we start talking about that, what hat are you wearing today?
Oh, I'm wearing my North Branch Nature Center hat. I'm the program director at North Branch Nature Center in Montpelier, and get to do all sorts of fun things in that role. But one of which is come out and be in the field with you all and Vermont Master Naturalist.
That's awesome. And you're running 2 programs this year.
Yeah, so we're running the Winooski Headwaters chapter of the Master Naturalist program, and so that kind of draws folks from all over the upper Winooski watershed, and we explore the story of that place. And we also run a Vermont Master Naturalist for Educators course, which is a week-long intensive, and every day is a different layer of the layer cake. So it's kind of our usual approach to exploring the layers of the landscape, but kind of all in one week, and it's all for 5th or 12th grade educators.
Which I have to say, that's a very fun program. It feels like just summer camp for teachers,
Yeah,
with a lot of educational material involved.
it very much is, yeah.
I love that you referred to the layer cake, because that's what we're here to do today. Is we're going to explore Boyer State Forest, and we're looking at it in this layer cake timeline way. We're going to start with the geology, work up to the cultural history. There's some interesting cultural things that have gone on. There's a quarry up there. And then we're going to end up in the present looking at what's living there now, but also eventually we'll be in Montpelier looking at a church, which I think it's just such an interesting arc to the story. And it involves 2 bedrock types. One of them is this Waits River Formation that's behind us, and the other one we're going to have to go hunt for in the woods, which is the Granite Quarry.
That's right.
So can you tell me a little about this rock type?
Sure. Yeah. Well, I always want to give a shout out to our road crews for being able to create the geology features that we need to see what's going on underground. When we're walking around in the woods and we're exploring the landscape, often we have tiny little clues of what's going on from a bedrock perspective. But really, to get a more full picture, you go find where a road has been cut out through the landscape, and you can see a big escarpment and really see a 3-dimensional context.
Sean, this, as we know, is the Waits River Formation, and it has some unique qualities about it. Like I've noticed that it breaks into these really platey shapes, which comes into the story later with the church. But what can you tell us about the depositional environment, like how this rock formed, how it influences the broader landscape around us?
Yeah.
Please tell me more.
So Waits River Formation, this is like the dominant bedrock formation throughout most of eastern Vermont. And it tells a really cool story because you can really put yourself back into what we call the depositional environment of what the landscape must have been like when this rock was laid down. So if you rewind 400 million years, and you imagine you're in Vermont, if you look to the west, you see the Green Mountains, but they don't look anything like they do today. They're huge. They're bigger than the Rockies. They're like approaching the size of like the Himalayas or something like that. And then if you look to the east, or actually where we are right now, we'd be underwater. So we'd be looking around at saltwater here. And depending on exactly when, this could be a big ocean, it could be a big kind of inland seaway. But the point is that we're underwater here. And for the Green Mountains to get from the size of the Himalayas down to the size that they are today, erosion has to happen, right? So the Green Mountains are eroding, and all that material in the Green Mountains are coming downstream, down watershed, and out into this underwater area, out into this big saltwater trough, essentially. And we see in this rock the evidence of that. So as we're looking at this, we're seeing bits of sandstone. So we actually, and as we look from this is actually a really great spot to look because as we kind of move from one side towards the other, you can see the grain size changing color as well as changing texture as well. Like right here, it's like really kind of big, fat grain sizes. Then it's much smaller over here. It's going from gray to black to reddish, right? And what this tells us is that this environment where this rock was kind of formed was a really chaotic one. So imagine again, you're in that canoe 400 million years ago in the water, and on a really stormy day, there's lots of sediment that's running off of these mountains and flushing out into the water, and then you get big deposits of maybe sand all across the floor of this water body. And then, maybe the weather's really nice for a few weeks and things kind of calm down. And so there's no longer sand dumping out into here, but those rivers and streams are carrying, silt and sand, silt and clay and like smaller particles. And so then we have, layers of much more finer sediment. And this whole area is, at the time, we're like down by the equator, like where we are in Vermont, like, we're not up at 44 degrees north latitude. We're actually down by the equator, which means this is a really warm environment too. So it's warm. There's lots of sunlight penetrating through the water. This is a shallow environment. So what does that make you think of?
Well, like coral and little critters living, and just this is depositing calcium.
Exactly.
Which can
Yeah,
really create a buffering capacity today in the soils that we see,
that's
in
right.
the
Yeah.
richness of the pH and the diversity of wildflowers and things in the region, and we have that in the Champlain Valley as well, these very calcium carbonate-rich rocks that buffer the soils and create more diversity in the plant life. So can we make this rock fizz?
So the cool thing about this Waits River formation is that some parts of this will fizz and some parts of it won't, because 400 million years ago there might have been a week that was where there was lots of calcium depositing, and then a week later there wasn't. And so we'll try to get some areas of this to fizz with this little bottle of hydrochloric acid, and that'll tell us how much calcium carbonate there is actually in the rock. So yeah, wish us luck.
Oh,
Oh, there we go. Yeah, you can see that little bubbling up right there. Yeah, nice.
so that's calcium carbonate giving off CO2 and creating salt and water, right? With HCl added to it, CaCO3. That essentially at the base of this reaction.
Yeah, exactly. And then so like right here, right on the other side of this divide. So this right here is what I'm talking about. Like this is where, perhaps, 400 million years ago, this was a different type of sediment that was laid down. And so we'll also fizz this and see if that reacts. Oh, even more so here. Yeah, that's cool.
That is cool.
Yeah. So we're just a few feet away from where we were before, and we're gonna try like right here on this rock to see if this fizzes.
Barely.
A little bit, but not
Little
nearly
bit.
as much as
No,
before.
it just
Yeah.
looks sandier. It
Yeah.
looks like it's breaking like quartzite in that spot.
Yeah, maybe we'll try right here too, just nearby to see what happens.
No.
Yeah, and so here
no
there's
reaction.
basically no reaction at all in this.
So it's intermittent throughout this road cut. There's some places where there's a lot of calcium carbonate and some where there's virtually none. So it's a really diverse formation, this Waits River formation, but a lot of it is enriched.
That's right. Yeah, I think people oftentimes people think that there's a clear-cut difference between limestone and sandstone and mudstone, but really it's a gradient, and these things can all be mixed together, and this is a great example of that happening. But the plants that are growing on top of this formation, they don't really care so much about what happened 400 million years ago, but they do care about whether or not there's that soil buffering capacity of that calcium carbonate. And so if we find an area that fizzes really well, that has a lot of that calcium, and we say go up to the top of the outcrop, and we look at what plants are growing up there, it's likely to be very different than what might be growing just 20 feet away in an area that doesn't fizz at all.
That's fascinating. So the two rock types we're concerned with today that we're exploring are this Waits River formation and then the granite.
The granite
that makes up the quarry. We'll talk about what granite does when we get up there. But it's interesting to know that perhaps as we're walking in, we'll encounter wildflowers because of this bedrock being under our feet.
Yeah, exactly.
Let's go walk in.
Okay. So Alicia, you see the chestnut-sided warbler right over here?
Yes, I did.
And then there's the indigo bunting.
I can't believe it.
But
Close
look
together.
at
What's
look a
on the
little
ground?
lower. What's
Yeah.
that over there?
I don't know. And where is Dave?
it's
I
like-
kept thinking Dave's going to meet us here.
Oh,
Hey everybody! What's happening?
Are you tracking things?
I'm actually under this apple tree because in the winter there's so many deer moving through here, and there's still some deer patterns, but it's really dropped off markedly. There's no apples on the ground, and the deer are out browsing in the forest, and in the field. So a little less activity here. So I'm out here poking around and seeing what we got.
So
Great to see you.
Thank you. What hat are you wearing today, Dave?
My hat?
Yep.
It's my Tilly hat. I call it my mushroom picking hat. It's also a tracking hat.
A tracking hat.
Yeah.
But you track with your own organization. You run a tracking program?
I do. Yeah, with Ondatra Adventures, I teach tracking courses and wild mushroom immersion course and a lot of naturalist skills and outdoor guided excursions.
Love it. Love
Yeah.
it. And this feels like a reunion because I first visited Boyer State Forest with both of you.
Oh, that's right.
On a
Yeah.
winter day about 2 years ago. We saw so much wildlife sign, lots of tracks and
Absolutely.
other things. I'm excited to go back up there at a different season,
Me too.
see what's going on. So let's hike in.
All
Let's
right.
check it out.
So many birds singing. Gorgeous spring day.
Go around the whole pond eventually. Yes, check this out.
Yeah, Dave, we're not the only ones. So we're here on the trail into Boyer State Forest, and we're already seeing deer tracks. So they're using this trail as well. What are they up to this time of year?
Yeah, well, like I mentioned down at the apple tree, they like many animals at the changes of seasons are after different foods. They adjust their behaviors to find those nutrient-rich foods. And the deer move from those sheltered forests and out into the fields more. They're really traveling about. And also, they have young too. The females have young with them, and they're really dispersing out over the landscape. So, you know, we've got this lovely little deer track here. And you know, if you look really close in there, I think there's another step in there. Here's the edge of one track and the edge of another right there. So what we have is a front foot landing on the ground and then a hind foot landing on the ground. The light is perfect. These low angle light situations where the sun's moving across the ground really gives us a lot of contrast.
Nice.
So this is a direct register, probably a walk. And you know, the truth is, hard ground tracking in northeastern forests is tricky. You really have to get lucky or find places that we call track traps, where there's mud or sand or silt or something that would really register a print on the ground. So something like this on a trail is not too uncommon, but I just want to point it out that we've got one track there. Of course, we'd have to do it.
Kept going.
Man,
Yeah, exactly.
we'd have to do a lot of work to find that next
You don't
step.
think it was pogoing up this trail on
No.
one leg? No.
We could find it if we spent a lot of time here, but you know, the deer, the white-tailed deer are here, and
Yeah.
you know, we've been up here and we've seen sign of bobcat.
Yeah.
We've seen of fisher.
Yeah.
I've trailed coyote, red fox, and porcupine up this way, and there are also bear too.
Yeah.
And I found fresh tracks across the hillside over on the other side of the property. A young bear and a mother bear just last spring. So I'm sure they're out and about, but these are some of the animals that we may see sign of.
Good. Well, we're off to a start with deer, huh?
Yeah.
All righty.
See what else we
Let's
find.
go see what we find.
Well, cool find, Sean. Tell us what you found here.
Well, we were just walking up the trail and noticed this spot here where it looks like all the leaf litter has been raked away by something, and seeing what looks like an impression in the middle of this area that's all free of leaves.
Yeah, it's super cool. You know, as animals are branching out and foraging through the forests and the fields, one of the things they're often after is underground tubers and even underground fruiting bodies or mushrooms like truffles. And you know, looking at this area, we see that's not very wide, and we can see all of the movement coming this way. All of the material has been raked this way. In fact, you can see some of the debris back here.
Oh yeah.
It's not too old. And check this out. Some of this grass is pulled this way. And then we've got a little something here that was,
yeah.
the tops were nibbled off
Huh.
right there and pulled out. And I might
Oh,
venture
yeah.
to say that something was eaten off of the bottom there.
Sure.
I don't quite know what that is off the top of my mind yet, but I bet you if we look around, we could find, I believe, a match to this jack in the pulpit. And last year, I did find sign of a porcupine digging up jack in the pulpit, eating the roots there and also nipping off the tops. And one of the things that lets me know that this is an animal with pretty sharp teeth is these cuts on these plants are really, really clean.
Yeah.
When a deer feeds, for instance, because it only has lower incisors, they bite and they pull, and it makes it really a ragged cut. And this, we may say, is an animal that is biting with both incisors nice and clean. That looks nice and clean to me. What do you think?
Yeah, nice and clean.
Hey, you guys, come over here. I found some mitrewort.
Oh, cool.
So, Sean, I think this is telling us about the enrichment in the soils here. This flower likes a more neutral pH. I love that that it looks just like a snowflake on a stalk.
Yeah, this is the first time I've ever seen mitrewort in central Vermont. We find it in the Champlain Valley quite a bit, but I've almost just stopped looking for it in central Vermont because it's so unusual. So just goes to show you spend time in the woods with Alicia and you find mitrewort wherever you are.
Well, I do love it. So, Sean, two of the common names for this is mitrewort, and the other one is bishop's cap. And for a long time, I would look at these snowflake flowers, and I was like, how does that look like a bishop's cap? But it's actually the seed pods. They open, and rain falls in them and disperses the seed. It bounces them out.
Oh, wow.
But if you were to turn them upside down, they have like ear flaps like old bishop's caps did. So
these mitrewort are potentially an indicator of what's going on beneath our feet, right? And I suspect if we keep going, we're going to find more indicators of enriched soil. So this might be time to start looking for other plants that are growing on top of that Waits River Formation, particularly like that calcium-enriched portions of that Waits River Formation.
yeah, I agree, and I'd be interested to see as we pass through the Waits River Formation and get to the Granite, if that changes. You know, are the wildflowers more abundant on this bedrock type? And my guess is they will be.
I think so.
Let's go see.
Check out this patch of wild ginger here.
Boy, that's just one more thing on the list of rich site indicators where, you know, the pH of the soil is closer to neutral. Let's try that here.
Okay, yeah, I have a little soil test. We can see if the soil is enriched. All right, so I'm gonna dig a little hole in the earth here to get down past the leaves, and then use this soil kit here to test the pH.
I'm seeing flowers, Sean. There are actually flowers on a lot of these
Of the
wild
ginger?
Yeah, so the wild ginger, the way we more easily recognize it is this heart-shaped leaf. It's got sort of a fine fuzziness on it. It's really a beautiful plant. And this is a whole glade of it right here. And if you look down close to the ground, you can start to see the flowers. And they're these sort of earth-colored, almost maroon little flowers that grow right on the earth. And they think they're attracting flies and beetles. The red color, and it has a bit of a stink to it, makes it attractive to things looking for carrion. So carrion flies, carrion beetles will come in and they pollinate this flower. And then ants later on will disperse the seeds. Dave, do you have another nice one over there? So the name wild ginger, Dave, has nothing to do with the flower. It's actually the stem and the root that have a kind of a gingery smell to them and taste.
Absolutely.
You know, people used to make ginger snaps with them back in the day when people didn't have access to the ginger that we do.
Yeah, and you can still check them out nowadays. Here's a little piece of the root. I didn't pull up the whole plant.
No.
But take a whiff of that and see what it smells like.
It smells gingery.
Yeah.
Kind of earthy and gingery. I'd eat that in a cookie.
Oh, for sure.
It's not as strong as the Hawaiian ginger that we cook with.
No, not at all.
But it'd do the trick if you were looking for some flavor.
Absolutely.
And you were all sort of farming the same small patch of land.
Yeah. And of course, nowadays, as far as foraging goes, we have to really be careful about what we're foraging and how much of it and why we're foraging it.
And I feel that way in general about woodland wildflowers, these spring ephemerals. A lot of them are ant dispersed.
It's so incredible. Ant dispersed.
Yeah.
So the ants will take the seeds and
Yes.
travel with them.
But not miles. Maybe 3 feet, 6 feet. These flowers and other flowers in these spring ephemeral families have eliosomes. They have little fatty
On the
packets
outside of the
that
seeds?
are attached.
Yeah.
So the ants will carry those off and eat that or feed it to their larvae and then throw the seed in the compost pile.
Well, basically, they bring it underground.
Yeah, they're planting it.
They bring it underground and they eat the eliosome.
Yes.
And then they leave the seed
That's
and the
exactly
seed
what
sprouts.
happens.
What a cool story.
It is such a cool story. Thanks for exploring it with me.
Yeah.
All right, we're ready to go over here, and we've completed our little soil test. So in here, we put some of the soil from beneath these wild ginger, and then put some powder on it that reveals the color. The color reveals the pH of the soil, and so you can see this is about a pH of 7.0, which on the pH scale in chemistry class is neutral, right? But as far as soils go, that's actually quite alkaline. So our soils in Vermont, the most acidic that we'd really find might be in the neighborhood of 4, 4.5, and the most alkaline we'd ever find would be something maybe like 8. So having a pH of 7.0 is really kind of proving our suspicions about this being a really enriched soil type. It has a lot of calcium carbonate in it.
So I remember the first time we were up here and we were coming up the trail and then suddenly everything changed. I feel like that happened this time too, and I'm looking behind us and looking around us and there are all these fairly square, sharp-angled chunks of rock. It feels different than
Yeah. So from a bedrock story, we're in a very different ball game all of a sudden, and it really is like walking past a sharp line. When we're walking in, we're walking through all this really lush forest with really dense ground covers and everything, and then we get to this spot, and the rock changes, and the plants all change, the tree types all change. And so when we were down there before we crossed that line, I picked up a chunk of the rock alongside the trail. This is that Waits River Formation
Yeah, it looks
stuff.
familiar. I see the red, I see the rusty color, I see the dark gray. Yeah, this looks like that road cut
Exactly,
this
yep.
morning.
And it is. And but now what's underneath our foot and behind us here is this. Very different, right?
Yeah, in this one I see a lot of individual minerals. I don't really see anything aligning in any particular way. So I'm thinking this is granite. Is that how it reads?
Yeah, exactly. This is granite. And so we were not the first to figure out that this is granite today. In fact, it's been well known. And so what you're holding is the bedrock geology map of the area. And so what we're seeing is that we are in this vast landscape of this Waits River Formation, the same stuff as the road cut. We're within this tiny little pocket of granite that was discovered, long ago. And so pretty much everything in the blue here, and this goes from Montpelier all the way south on this map. So this is Berlin Pond, here's Montpelier all the way up to Worcester. All the blue is that Waits River Formation. This purple is kind of a closely related member of that. But this little tiny stripe here, it's called DBG, which is just the code for this rock type. This is a little granite pluton.
That's amazing. And you said we weren't the first to discover it. I mean, clearly it's been quarried. I mean, somebody was up here taking this rock out.
That's right, yeah.
And turning it into something else. What? Tell me more about that.
Well, so, if you imagine, whether you're the first geologist or whether you're the first, person looking to quarry rocks coming through here in the 19th century, this wasn't forested, this was farmland. So it would have been a lot easier to find where that line was. It would have been easier to notice when things suddenly changed. And these granites are fairly rare in the landscape. At the scale of Vermont, granite is fairly rare. There's places like Groton State Park, or, State Forest, the Barry granite quarries, of course. Mm-hmm. There are places where we do have lots of granite, but by and large, granite's hard to come by. And this spot that we're in is this tiny little slice of granite that was utilized by folks for quarrying for maybe about 50 or so years, from mid 1850s all the way up to about 1900, just prior to 1900.
So I'm trying to picture this. This was someone's farmland, and we know who that was.
Yeah, yeah.
So we'll talk about him in a minute. But anyway, land was owned, the granite's discovered. He sells the mineral rights to
To the West Berlin Granite Quarry, yeah,
Okay.
which you know, the headquarters of that operation were down on the Dog River along the Central Vermont Railroad, and it's possible that this was quarried kind of informally on and off for 20, 30, 40 years, and in fact there's some newspaper articles that suggest that, and then it was sold kind of formally to this West Berlin Granite Quarry, where it was, you know, a real operation for a while. And so it would have been so interesting to see just what this landscape looked like before, because in many ways there's been a big scoop taken out of this landscape, and that rock has been used for various different things, including the church downtown that we'll check out later on.
Visit later.
Yeah.
Yes. So the gentleman that owned this land, I just remember reading this rather sort of. I think it was his obituary, and there was a little bit of throwing of shade on this individual. Do you remember this story?
Yeah, it was something. Maybe we can read it in a minute, but it was something like, yeah, the person was, you know, well respected and you know, a financier in town, and generally did very well economically and for most of his career. But then things started to slide, which was evidenced by the fact that he stopped paying his subscription to the local newspaper, which is the newspaper that was publishing his obituary.
And they mentioned that.
Yeah.
They said he owes us money.
Yeah.
I thought that was kind of a small town thing.
Yep.
So I'm interested in how this operation changed the surrounding landscape.
Yeah.
You know, and we both were under the impression when we walked in here that there now is new habitat for different animals as a result of this pit that was dug and the rock that was strewn aside that wasn't used. So
yeah, it's an interesting case where heavy human disturbance actually in the long run created a lot more topography and and diversity of habitat than would have been here before.
which I think is kind of not the way we typically think of it. And granted, granite does not have heavy metals in it, so there wasn't anything polluting
Right.
associated with it, like if it had been a copper mine.
Yeah.
So Sean, we're seeing not only are these blocks quite angular and blocky, but there are marks from the tools that were used when they were quarrying this granite. And I'm trying to picture what this landscape would have looked like. So this is back in the mid-1800s. How were people working this rock?
Yeah, so early on when this quarry first started having rock extracted, you would drill a small hole into the rock. You try to find where the grain was of the rock to the best of your ability. And then every 6 or 8 inches or so, you drill a small hole and you put a couple of metal wedges in that hole. And then with a hammer, you go up and down the line, you tap each one. And you'd keep tapping them and driving more and more pressure into those wedges until eventually the rock would split along that grain. And as technology improved and you know, equipment got better, we start seeing bigger holes, deeper holes, dynamite used, that sort of thing. But
Wow.
at the time that this was done, we're talking just hammers and metal wedges for the most part.
And then they had to get this stuff down the hill
That's right.
and into town.
Yeah.
And was a lot of that oxen and horses and
Right.
you know,
Yeah. Oxen pulling wagons. There was a newspaper article in the same that same newspaper announcing that, you know, such and such person in town had recently been employed by the West Berlin Granite Quarry to bring slabs of rock from up here down to the factory in the Dog River, saying that he would be gainfully employed for a long time doing that.
Wow. Sean, one of the striking things when I first came up here with you and Dave was this pond. You know, this is just standout image of the landscape right here, and you can just see it. And it's full of life. You know, we started exploring and we saw all kinds of things in it. Should we see what's there today?
Sure. Yeah. Yeah. So here at the edge of the pond, looks like there's some egg masses of spotted salamanders in here. I'm looking to see if any of them have hatched and if they're still viable. We'll see if we can take some out.
Oh, wow, there are a lot of them.
Yeah, there's so many more underwater too. You can see like they're green because this out here, this is maybe a little bit better. They're green because there's algae inside the gel of these eggs.
Have you seen
It's
anything?
looking like there's there's nothing that's moving around in there. By this point in the year, these eggs should be hatched by now, and so we'd be able to see the little salamander tadpoles wiggling around inside the eggs, but not seeing that right now.
But this
But
is
there's a
the green
a
frog.
green frog over on the other side of the pond calling.
And but this is effectively a vernal pool, even though we know it doesn't dry out because it apparently doesn't have fish in it.
Right.
What it does have in it, I know for sure, is leeches.
Plenty of leeches. Maybe it'll be some on my arm in a second here.
You can set your hand in there a little longer.
Well,
I remember seeing some in here that were like 5-6 inches long. They were and they were just like ribbons, like hair ribbons.
And also, even though there's no, looks like these eggs are not viable underwater, I can see there's like snails that are eating on, like there's plenty of, like this is still a food source to everything else in here.
Hey, Alicia, come check this out.
Wow. We were just talking about the vernal pool that was created when they quarried this landscape. And this rockfall itself seems like it creates habitat. Can you tell us what you're seeing here?
Absolutely. This is, I mean, look at this thing. It's so unique. We've got a tree with the top portion of it is dead and the bottom half is still alive. And this tells the story of one of the animals that has made this abandoned quarry their home. And if you look at the end of each of these branches, we see a 45-degree angled cut.
Pretty thick.
I know.
Pretty thick branches that it chewed through.
Yeah, every single one of these is trimmed. And this is feeding behavior of the North American porcupine. And what's really cool is that if you follow this down, you'll see some other patterns.
Yes.
Right here where the bark has been stripped away. And these are old scars.
Yes.
They've been grown over. Then at some point, all of these branches were nipped and eaten as winter food for the porcupine. And if you go further down, this is a really fascinating story of this tree. It's still alive.
Yes, it is.
But it's only alive below a certain height.
Right.
And you were pointing out something cool about this, an observation you had. What do you think's happening here?
I was thinking that if you bring in the winter snow and if it weighs this down, it could shelter it from the winter feeding.
Yeah.
That these lower branches are invisible to the porcupine under the snow at certain times of year. Do you think that might be what's going on?
I agree, and I think that's a really cool analysis. I think this hemlock is buried in snow during the winter up to a certain point, and that prevented this tree from being fully stripped. Because if you are a porcupine and you're this tall, and you stand up to this tall, the first thing you would eat is this. Why would you climb to the top of the tree?
Right.
It's right here, unless it tastes better. But I think the snowpack is
the answer
story here.
Yeah, and it's on both sides. I mean, it's almost like the opposite of a deer browse line.
Yeah.
Where like the cedar get chewed up until about 3 feet off the ground.
Yeah.
Here the hemlock was buried in the winter snow, and the porcupine didn't get to it. Yep.
Amazing.
But they're pivoting their feeding habits because it's spring going into summer.
They sure are. This is winter feeding behavior, and this is one of the conifers in the area, and this is what they predominantly feed on. They feed on the needles and the inner bark, the cambium of these trees.
I did notice, Dave, it didn't completely avoid the trimming, but some of it survived.
Just enough, yeah.
Enough to keep the tree alive.
Yeah, I mean, that could be like late winter, early spring feeding right there.
When the snow starts to melt.
So all the porcupine now that have called this quarry their home, have moved from the conifers and now have moved into eating buds off of deciduous trees and drinking the sap of maples, and then eventually into moving to the ground and spreading out so that they're now moving into field habitat and eating herbaceous plants.
And things like jack in the pulpit.
And things like jack in the pulpit, yeah.
So, but you saw some tree browse. nearby. Can
Yeah,
you
there's
show
some
me where
really
that
cool.
was?
Yeah, let's
Yeah,
check
I
that
haven't
out.
seen that yet.
So Sean, I want to show you this little thing I found here.
Whoops.
Can you see this trail?
I can definitely see a trail. Yeah, it comes right through here, goes up between those trees and off in the distance, and then it continues this way, right off that, past the main trail, and then off into the distance. It's quite prominent.
Right. Yeah, this is the trail of one of the animals we're seeing sign of right up here. You can see it's not very wide, and there's some indication that it could be short. There's some plants there in the way.
Right here, yep.
And it wouldn't restrict a tall animal from coming through, but it's giving us some indication of its size. And then, like you said, it passes up there and actually goes through and
Underneath
under
all that deadfall.
all that deadfall. And if you can put your hands down in the trail, you'll feel that it's very compact.
Oh yeah.
This is used regularly and frequently by this animal. And the browse sign that I saw in the forest is right up this trail, and that's how I found it. I just followed this trail along. So let's go check that out.
Okay. I'm just observing that like the moss is intact on top of this, and if this is used a lot by like deer, for instance, I would imagine that moss would get like eroded away.
Yeah. So that trail comes right through the woods, through that deadfall, and it's very predominant. It comes right under this fallen log and travels up. This is regularly used. Quite amazing. And Sean, you pointed out that the moss is still intact in a lot of these areas, indicating that these animals that travel this way don't have very, well, we could say, sharp hooves. It's not a lot of deer travel. Otherwise, the deer would be digging up this moss just in their movement. So check this out. I followed this trail up. We found some evidence of this animal creating something called nip twigs. You can see here, we've got a 45-degree angle, just like that hemlock tree we were looking at down at the quarry site. And we know that that's porcupine, and this is also porcupine. What's really cool about this is that this branch was nipped twice. Nipped once from the tree right there and it fell, and then nipped another time down at the ground. Now, porcupine will exhibit this behavior when they climb out to the end of a branch that they're interested in feeding off of, because their body weight, of course, wouldn't be held by this, pardon me. And so what they do is they sit up in the tree and they pull the branches toward themselves and feed, or they'll just chew that right off and let it fall to the ground. And then they'll come back down to feed on it. What's really cool about this is that it's incredibly fresh. If you compare these two leaves, on my left here is a fresh beech branch with, really fresh leaves, and on my right, wiggle in here, is the nip twig, or the nipped branch. And you can see it's just beginning to wilt, and we've had a few warm days here, so this is not very old. And I suspect that nearby is this porcupine that did this. I'm a little curious to know what exactly it was planning on eating. Is it going to eat the leaves? All the buds are opened up, the leaf buds are opened up, so it's a bit of a story. And we could spend some time tracking this out, or coming back up here, or following that porcupine trail to see what exactly they're doing with these beeches. And
So you think these twigs match porcupine teeth?
I think so.
Would it be fun to compare that?
Yeah.
Yeah, I wish. Hey,
only if we had a porcupine skull.
I think I have a porcupine skull in my backpack.
Get out of here.
You have a porcupine skull?
Sometimes I carry a porcupine skull with me.
There's something I heard one time about someone finding beavers up in the forest, way up in the mountains. And
I think I know that story.
you know that story. Well, it turns out I don't think those were beavers up in the forest after all.
Well, let's look at both of them.
Yeah, because I got a beaver skull in my backpack.
Do you have a
Get
beaver
out
skull?
of here.
Yeah.
Oh, it's even labeled, so that's how you knew it was a beaver.
No, I
right?
just found this in the woods. I like that.
There, that's a beaver. That's how you know it's a beaver skull. These two skulls are so unique. I mean, if we look at them,
They're quite similar.
They're quite similar. Can you all see those okay?
To my eye, and I might be making this up, but I almost feel like the beaver's eyes have migrated over time evolutionarily to where they look sort of up out of the water more. They seem like
Yeah.
they're a little more oriented to look up
Yeah.
than a porcupine.
They absolutely
Yeah.
are, and that's indicated by their evolutionary adaptations. They're always in the water, right? That's where they're safe. That's where they're feeding, foraging, etc. So their eyes have migrated over time, we could say, to right up on the top of their heads, and the porcupine have remained towards the side of their heads still. What's really interesting are the teeth of these animals. Now they're
Yes.
both rodents,
Yes.
so their teeth grow continuously. Hence this huge long curl of dentition. And they'll continue to grow, so they need to chew and feed and trim those teeth down. Also, both of these animals, they have developed the ability to hold on to iron. And that's in the very front portion of their enamel.
Yeah,
And-
that's what's fascinating to me, Dave, is the front of their teeth wear more slowly than the back of their teeth.
Right.
So they're always kind of chisel shaped.
Yeah.
Isn't that that's
Yeah.
such a cool adaptation.
So the front is longer and the back is the part that gets trimmed down.
Yeah.
So
Wow.
these
I do kind of think of porcupines as tree beavers. I mean, they have a lot of the same dietary inclinations, right?
They sure do. Yeah, for sure. They're both herbivores. Beaver eat the inner cambium, or the inner bark, the cambium of trees, and porcupine do as well. They both eat vegetable matter throughout the year, throughout the summer. They'll also eat aquatic plants, the beaver and the porcupine. So what's really cool is something that not a lot of people are aware of. Beaver and porcupine, what they do is they grab onto, let's say, a tree trunk like this, and they latch their front teeth, and then they move their bottom jaw upwards. And that's how they scrape the bark. That's how they open up the bark, and that's how they would strip the bark off of a tree. A porcupine, let's say, exhibiting winter feeding behavior.
Wow. That porcupine is a young one.
Yeah.
So they are often a little closer in size than these examples are showing us. I think big porcupines might be 40 pounds. Little beavers might be 40 pounds. They might overlap a little bit in size. But beavers can get to be like 70 pounds or more, right? They're big animals.
They are huge animals. And porcupines are no joke either. They get pretty large. And
Yeah.
when you see a porcupine on the ground, it's quite beautiful because, you know, they're protected by all of those quills, so they behave as such. They don't run away.
Right.
They don't really do much. They just acknowledge you, and they'll turn their body so that their quills are facing you. If you are an active threat, they might click their teeth at you too. And I've had a few occasions where I've accidentally cornered a porcupine in a barn or something, and they just turn and look at me and chatter their teeth. It's kind of intimidating because you know they got some pretty powerful
you can see
jaws.
that big teeth.
And then they turn around and they put their face up against a hard object, maybe the base of a tree or a rock or something, where their front half of their bodies protected their face, and then they use those quills, which are on their rump and tail, to protect themselves. The musculature raises the quills, and when they're really frightened, they'll swing their tail back and forth. What's really interesting about those quills is they're hollow, and once they embed in the flesh of a threat, they're barbed in such a way that they get pulled in to the body
Wow.
through time. And if they don't hit bone or something like that over time, they'll pass right through a limb or finger or whatever, nose, if you're a coyote trying to eat it. So I certainly feel bad for all those animals that try and eat a porcupine and don't know how to. But man, good for the porcupine, right?
Yeah.
Good for them. And you know, they're so sweet and lovable in
I
many
agree.
ways, just because they're not entirely fearful.
Yeah.
One of the downsides to their defensive behavior is that when they're crossing roads and a car is coming, they don't run, they just freeze and turn to face the car, which is, you know, potentially the threat. So they haven't figured that out yet, or
Yeah.
it's not part of their survival strategy to run from cars, at least not well.
So we have this theory that I'm going to call it talus. The talus that was created by this quarrying operation is kind of a porcupine city now. I mean, a very dense number of porcupine are living in and around that rock fall, that slag, you know, from the quarry. Should we go there next and see what sign we see there?
Yeah, in fact, I think that's a great idea. You know, before we head over there, you know, the porcupine really need conifer trees to make it through the winter. And we saw that one hemlock down by the water, by the quarry, and we see tons of sign of porcupine here. But if you look around this forest, how many conifers do you see nearby? Do you see any?
Not very many. I
Not
guess
really
we see
much.
one spruce. Yeah, no, very,
So-
very many.
There's a good reason why the porcupine are here. If it's not specifically food, it's very well likely denning habitat. So I have a hunch if we follow this trail a little
It'll take us
further,
back that way.
we'll find some other sign of porcupine
All
in
right.
this region. So check it out.
I love that idea.
This is the Porcupine Trail, and it's right up, traveling right along all of this spent stone from the quarrying operation. And check this out, Sean.
Oh yeah.
We've got our first clue here that it is in fact porcupine. Because up until now, it's been, you know, you've just been believing me, and you're using your own observations and knowledge you have about this. But
Sure enough, yeah. I was about to put my knee down on this and decided bet against it based on the quill here that we have.
So now we have really clear evidence that this is porcupine habitat, and they're traveling up this trail and winter feeding on the conifers. Early summer, late spring, we're in late spring now, feeding on deciduous trees and jack in the pulpit. And we've also got some scat in here that will give it away. I generally don't pick up scat, but when something's an herbivore and it's been sitting around for a while, there's very little concern.
Sure. I mean, it just looks like sawdust when you break it apart,
Yeah.
right?
Yeah, you can tell exactly what they eat, right? And this is all their winter feeding too. It's so coarse, it's basically wood chips. All animal scat change with their diet, and their scat will change also with their summer feeding. There are thousands of tons of granite just piled up here, and there's caverns and pathways, and it's really spectacular. So here's another great example of that porcupine feeding on the inner bark of these deciduous trees during the winter. This is a winter feeding behavior. You can see all these cool different angles of patterns of designs that their incisors make while they're locking their front top teeth and just dragging their lower jaw along.
What we were noticing is that this porcupine has girdled this tree all the way around, right? Which means there's no longer any nutrient coming up from the roots, and yet this maple still has leaves on it, which is kind of a way to clock the age of this feeding too, right? Like those buds have opened up and those leaves have come out, but they're already starting to look kind of wilted. And so yeah, this is definitely from this last winter.
Yeah, so this isn't really old. This is fairly recent. And something you pointed out that I love, and I'm often looking for this with animals that climb trees, is what is all this here, Sean?
Yeah, it looks like claw marks running all up and down this.
Yeah, there are tons of claw marks on this tree of these porcupine just grabbing it and sliding and grabbing it. And if anyone's ever seen a porcupine climb a tree, you know they're prolific climbers. I've seen a porcupine climb a tree with only 3 legs because the front was injured and withered and pulled in. And it climbed up that tree just as casually as a porcupine with 4 legs.
Wow.
It was really incredible. So something that I'm also thinking about this place is the sense of time, and you talked about it when you were aging this event here of this tree being girdled.
Mm-hmm.
And I've been thinking about this location in terms of generations of porcupines. And we've got this huge, huge pile of stone that's been left from the quarry operation. In what time frame do you think that would be?
Oh, I mean, that was the latter half of the 1800s. Yeah.
Man, so we've got multiple generations over and over and over of porcupine that have been making this place their home.
Mm-hmm.
And it's just really fun to think about the great grandmothers who were living here and colonized this place.
And shaping the forest around them as they went, right? These trees are responding to this porcupine browse over the span of generations as well.
Mm-hmm. Truly incredible when we think about that.
So we've been out here on a lovely late spring, going on towards summer day, looking at all kinds of evidence in this forest. We started at the road cut, just to understand what was under our feet for most of this hike. Ended up at the quarry where we've run into the granite. There's still mysteries in the woods that we're trying to think about and put into context, but clearly this had something to do with hoisting rock up out of the pit. We're going to go next to the church, so we have one more stop before our day is over. But what will you remember from today? What struck you about this adventure?
For me, just imagining generations of porcupine colonizing this right on the heels of this being an active quarrying operation after it was abandoned. Yeah.
Just the potential and the...
Yeah. Or that, you know, this story, we're telling the story of the quarry from 130 years ago, but there's continuity of that story to today.
Yes.
Through the porcupines
and
other things.
And the church.
And the church.
And other things. What will you remember?
Right. I think, you know, also I'm thinking a lot about time. You know, also with the generations of porcupine that have inhabited that rock pile there, the granite pile, and also just thinking about the use of this stone, why the stone was harvested, and what life was like at that time. You know, all of this was done by hand and by horse or horsepower, and I imagine it was not easy, and it was difficult and challenging, and probably a lot of injuries happened up this way. And seeing some evidence of some of the operation is really interesting too, beyond just the stone that's left behind. And you know, I just love how the natural world, biological organisms inhabit the space that is there. And that's one of the cool things that we as naturalists get to see, is that there's, you know, primary organisms that come in first, and then there's secondary colonizers, et cetera, and then there's organisms that will stay over decades and decades because it's just right. Or in the case of porcupine, they're making this place their home, not necessarily because there's great winter food, but because they've got a safe place to live all through the year.
Right.
Yeah.
I do find when I see porcupine cities, just lots and lots of porcupine evidence. There's often rockfall nearby, just somewhere, crevices where they can raise their young, hide from predators.
You know, and we've only been talking about porcupines.
Right.
There's other animals that use that too.
Yeah. Bobcats.
Fox, bobcat.
Yes, exactly.
Oh, so many animals.
That then the pond too, the quarry pond, is full of its own host of life, salamanders and frogs and all the things that hunt those things, like the bobcats, like owls, like, you know, whatever else. So there's an aquatic and a terrestrial ecosystem built around this quarry disturbance.
So I guess we're going to go see some of this rock in the present in a building that was built at the time this quarry was active.
That's right.
Sounds like a good way to close the loop on this whole story.
Sounds cool.
Thank you both. Yeah.
Thank you.
So Sean, one of my favorite parts about all we've explored today is this church. And you found it. There's a story built into this church.
Yeah, so we're at the Episcopal Church in downtown Montpelier. We're right on the corner of State Street and Elm Street, and you can see that this church is built out of this beautiful granite. And this is the granite that we've been exploring all day up in the quarry. That rock was quarried to make this church. But there's another fun surprise around the back side of the church that'll continue telling the story. I think we should go over there.
I love that surprise.
Great.
Let's go back. So Sean, around back, this looks like a completely different church. Can you tell me what's going on here? I mean, we're still behind the Christ Episcopal Church.
That's right, and you'll recognize some of the granite in here on some of the sides of the chimneys, but most of this now is the Waits River Formation. So that main type of rock that was all around the granite quarries that we were at, where that pluton of granite came up and bubbled up through the surrounding rock, well, this is that surrounding rock. You can see it's kind of that flat horizontal rock that has that kind of rusty quality to it. Looks just like the road cut, right? And so we have one building here right in downtown Montpelier that is telling this entire story of our bedrock geology from our site today. So the front of the building, all granite, the back of the building, all Waits River Formation.
So I have to guess there's a reason for that. Why do you suppose the granite's up front and the Waits River's around back?
Well, this Waits River Formation rock is, it's crumbly, it erodes quickly. It's not as, I think it looks really great, but it's not as nice looking, it's not as precious of a stone. And so I think they just tried to hide it in the back side of the building.
Cool. I love that story.
Yeah.
Okay. Well, and you have something.
Yeah, I'm wondering why you handed me this box here.
Well, I brought you guys some treats.
Nice.
But you have to earn them. So
Okay.
we've been talking about bedrock and habitat, and what animals do you think of when you think of a church? Like, what uses a church as habitat?
Man, so many animals. I think of bats.
Bats.
Old churches
With
filled
the
with
steeples?
bats. Yeah,
Okay,
with the
that's
steeples.
that's one
Pigeons.
answer. Pigeons along the edges.
Yeah,
Anything
along
else?
the
Anything
edges.
else? Famous animals related
Famous
to churches?
animals. Mice.
Mice.
Rodents.
Mice.
Oh, that's great.
Wow.
Thank you for joining us on another Vermont Master Naturalist hike. Come with us next time and we'll have another adventure. Enjoy your mouse.
Thank
Are
you,
gonna
Alicia.
eat the nose first?
Absolutely.
Just the nose.
Poor mouse.
No, it
Wow,
can't
that's
smell.
delicious.
They're pretty darn good. Can I just say, there's an amazing film about vernal pools called Life in Spring Pools that's on the Vermont Master Naturalist YouTube channel, and people should watch that.
It's a good one.
They're fairy shrimp. Do I need
There
to
are
say
fairy
more?
shrimp. Nope.
Fairy shrimp will
Fairy
do it.
shrimp, yep.
Okay.